and the length is going to have an effect. So we're going to give an example here. If we have a man, and if we have a woman, let's listen to this example. All right. So who do we think is making this sound? The child. And because children are smaller than adults, they have a shorter track that the sound is going through, so it tends to be higher, much like this sound was higher than this sound. So, yes, you're right, it's the child. So this sort of hints at this problem that psycholinguists, not psycholinguists, by the way, although those do exist as well, that psycholinguists look at as the lack of invariance problem. And the lack of invariance problem is just a complicated way of saying we have a lot of variance. There's a lot of diversity in the speech sounds we encounter. So it's a lack of one-to-one correlation between the acoustic signal, so what's hitting our ears and our brain, and the way we think of sounds. So if we think of it this way, how many of you have run a search through a book and you're trying to find how many instances a book mentioned a particular word, or if you're writing a paper and you're trying to find words? Sometimes you'll run into a case where it will show up in a different word, or sometimes instances of that word won't show up in your search because it's slightly different. So this is the same way. There's so much variation that it doesn't map into our brains one-to-one. So the way we think of sounds. This comes from acoustic variations, which is what we talked about, which is, you know, different people are producing different pitches of sounds, different quality of sounds, different timbre, all of these different sort of acoustical variations that are packaged in the sound. Another type of variation, where we're going to get more into linguistic speak, is allophonic variation. So allophonic variation is variation of allophones. And you're going, Kelsey, what's an allophone? So allophones, phonemes, these are some special linguist terms. So these are defined broadly. Linguists divide speech sounds into these two categories. So if we think of phonemes, so both of these have pho in them from the root, meaning sound. And if we think of phoneme, we're thinking of it's the target. It's the thing we're searching for. It's the idealized form of that sound. It's not the spelling, because linguistics is about speech, not about writing things down. It's the sound we think we're saying. Whereas the allophone is the real sound that's out in the wild. I don't think we all produce, you know, specifically perfect does every single time we say them. And we'll get into that a little bit more. So with this allophonic variation, we have two kinds. We have one-to-many, and that's the following. So let's take the sound ta. This is not the letter T, this is the sound ta. And in American English, the sound ta shows up in several different words, as you can imagine. We have trumpet, we have butter, and we have what? But if you listen again, if you listen to what I'm saying again, you'll notice that this one sound T sounds like ta, okay, trumpet. But then when I say butter, it's more like a da. This is specific to American English, by the way. More British Englishes will still pronounce it as butter, and that's the difference, one of the main differences. And this last one, if you hear me say what, it's this special symbol that means glottal stop. It's being cut off in my throat. And this is kind of a key component of how many of you have heard of the Californian way of speaking? What's going on? Like a lot of glottal stops. So we have this one idealized sound, but out in the wild, it's showing up as ta, da, and So, okay, that's a lot of different sounds and a lot of different inconsistencies. Similarly, we have many to one. We have this word matter in English. And we also, in American English, have this word matter. Oh, these are two theoretically different sounds that are mapping onto the same sound out in the wild. So, this brings us to what your poor brain is doing with all of this. We have all of these variations. We have dialectal variations. We have age, we have gender, we have many to one, one to many, so much sound. And we're just talking about speech sounds right now. So how is our brain not going? Categorical perception is how your brain solves this problem. It's the process by which the brain organizes these speech sounds into categories. And what you'll see up here is a chart with all of the vowels of American English. And these circles denote areas where a native English speaker from America will accept variation and still map it as that sound. So a sound doesn't have to be only E perfectly every single time for somebody to hear it as E. They'll accept variations to a certain extent. If somebody is talking to you in a strong accent and your brain is going, I don't understand, it's probably because their acceptable variational circle is much broader than yours is. And so your brain is going, you're saying totally different sounds. So this is categorical perception, and we know that this is happening. We know that the brain gives us these sorts of realms and boundaries because of these tests. So we're going to, again, do some more sound talk. If we compare the sound B to the sound P, I want you to put your hand on your throat. And I want you to just go P, P, P. Okay? Some of you aren't doing it. You should do it. Oh, okay, okay. Oh, okay. Now I want you to put your hand on your throat and say the sound B, 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 B. Okay, so now put them together. B, 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 B. What's the main difference you're noticing right now? Is there, are you okay, you're feeling things happening when you're saying ba, because you're voicing things. It means that your body is producing noise at that point. So when we take, that's basically simply the only difference between the sound ba and the sound pa as far as linguists speak of them. It's called voicing. So pa is unvoiced, ba is voiced. And this becomes especially noticeable when we put a vowel, and vowels by and large are always voiced. I mean, if you can make a vowel without a sound, let me know. But if you put a vowel next to it, then there's always going to be a little bit of time between when pa is released and starts. Whereas for ba, it's already voicing. So that time between when we release the stop, b, and the start of the vowel, is going to be much shorter when it's ba. So it means we have this whole continuum going ba, 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 ba. And we think, sounds over here are very ba-like, and sounds over here are very pa-like. And somewhere in the middle here is where we have our categorical boundary. And that divides this spectrum into two different sides. So, basically, categorical perception says that we will accept variation along this spectrum all the way up to a certain point, and then past that point, your brain will say, nope, nope, this is pa. These two sounds might be totally, like, barely different from one another, but if they straddle a categorical boundary, your brain will be like, no, one of these is ba and the other one's ba, dude. And so we can see this. So VOT, that was what I was talking about, where ba has a very short VOT and pa has a very long VOT, because ba it doesn't take very long for the voicing to onset, and for pa, it takes a lot longer. So if we look at this graph, we see, okay, as voice onset timing increases, as we have longer and longer ba, pa, 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 more and more people are counting the sound they hear as pa, so pa-ness, percentage-wise. And you can do these experiments, and you'll find that between a certain range, here it's between, looks like actually 25 and 35, at some point in there, people are like, nope, this is a pa, definitely, and this is a ba, definitely. So that's the basics of categorical perception, and this happens for all of these different sounds that vary for just one feature. And your brain is doing all of this right now. It gets better. So there are many influences on categorical perception. Your native language, for one. Your native language will affect your categorical perception, and this happens very, very, very early. When you are a tiny, tiny baby, your brain will contrast between way more sounds than you can contrast now. But what happens is, and they found evidence that this is even happening prenatally when you're still in the womb, that when you hear your parents speak in the target language, the baby's brain goes, ha, I need to focus on those sounds. I need to focus on those sounds. All these other sounds, I don't need to think about them anymore. I just focus on these. And so this begins to narrow more and more and more. A most notable example that I think we're all kind of familiar with is native Japanese speakers distinguishing between la and ra. In Japanese, those two sounds do not contrast. And so if you have a categorical perception test where you have la on one end and ra on the other end, they're going to be like, these are all, what? Because it doesn't contrast. And so it's very difficult to hear and then produce these two different sounds consistently. I noticed this problem when I started learning Serbian. And you have the soft ch and the harder cha. If you might have noticed, I can't really do them that well. So likewise, I can't really hear that, especially in rapid speech when people are speaking. I'm like, it kind of sounds similar to me. So, but with careful practice and with a lot of listening, you can begin to detect, because your brain is somewhat flexible when it comes to this. So another influencer, your brain generally has this sort of static thing, but it will temporarily shift these categorical boundaries in order to accommodate variation. You've noticed this when you're listening to somebody with a very strong accent, and at first you're going, I don't understand, and then by the end of the evening, if you're hanging out with them, you probably should be able to understand more and more, because your brain begins to say, aha, this is systematic, I'm going to pick this out, okay, I'm going to temporarily broaden my categorical boundaries. Likewise, they've done experiments, and your brain will do this for words versus non-words. So let's go back to our example of ba versus pa. So normally we have our contrast at right around here, where people are distinguishing between those two with ba on one end and pa on the other end. But if we have ba on one end, which isn't a word in American English, and pa, Lady Gaga, put your paws up, is a word in American English, you will see that people will temporarily shift their boundaries so that way they're hearing pa for longer, because their brain will say, well, it couldn't have been ba because that's not a word. It has to be pa. So they'll shift their boundaries to accept a shorter VOT, even though they should be hearing it as ba, they'll hear it as pa. So that's another influence. So if you want to test your own categorical perception, this is my chance to plug what I have been working on. Go to this website and sign up. You take a brief little survey at the beginning, and then you have two parts of an experiment. You have one that's very similar to just this labeling example, and the sounds tested are for ba, da, and ga, which vary along a continuum for one feature. And you will do this labeling task. And I just did one this morning. My categorical perception is doing really well today. Right here, we'll see I'm labeling these sounds very consistently. Aha, I'm hearing a ba, and these are all shifting, by the way, for this one feature. But then, aha, over here, I now hear a da, okay, and right here, okay, now I hear a ga. Everything's working pretty well. The second part of the test takes a little bit more knowledge to get into, and this still works as a good result, and I'll tell you why. Categorical perception, think about it with me. If we have a boundary right here, we should be able to tell the difference between two sounds when they're presented in a pair if they're crossing that boundary. If I'm hearing one as pa and the other one as ba, I should be able to tell the difference and tell me things about the order of these two more consistently than for sounds in their own category. If I'm hearing them as the same sound, I'm sort of like, is it more ba-like, more da-like? I don't know. And so you'll see here that this correlates with the crossover between ba and da. Aha, I'm able to categorize when things are crossing this categorical boundary. Aha, and things are also very high as we get closer and closer to the actual da and ga line. In between, things are a little bit spottier. So go online, test it out, and take a snapshot of your results, test your friends, compare your categorical perception, bookmark it, because we will be adding more sounds, we will be adding more contrasts, and that way you will hopefully, I'm hoping to do one with cha and cha at some point, and I think that would be really, I'm not going to be recording the sounds, by the way. So, what we've covered, just a brief summary of what we've covered. We've covered a little bit about linguistics and the subfields within there. We've talked a little bit about phonemes, allophones, how linguists talk about language. We've talked about the speech tract and how it affects the sounds we make. Don't make me make these sounds again. We talked about categorical perception and how we use that to sort these sounds into meaningful units. And we talked about how categorical perception is affected by other factors. So, if you thought this was interesting, I'm going to invite you to follow in the path, or follow in the words of a famous Jedi, and join me. We will probably not conquer the galaxy as father and son, but we will study linguistics together, and we will learn more about how humans interact, how we produce language, where our languages came from. We can do language reconstruction. Consider that. So many thanks to the Mary Ellen Ryder Linguistics Lab, which was the lab at my alma mater at Boise State, the Student Research Initiative, which was where I got the funding to do this, my undergraduate advisor, and the guy who made, if you go to that site, the demonstration at Holsinger, he made that, and the festival for having me here, and Ivana. So thank you so much. And you, I forgot the most important part. Any questions before we go? Nope, we're all good? You all perceive language?